So this question involves matrix multiplication. We are asked to find the value of P, which is a variable. So we have a 2 by 2 matrix. I'm multiplying it by a 2 by 1 matrix. So there's a 2 by 1. So it's rows by columns. So this matrix has 2 rows and 2 columns. This matrix has 2 rows and 1 column. So the result is going to be a 2 by 1 matrix, which is what this is, 2 rows and 1 column. Remember, for you to be able to multiply two matrices, these two values have to match. Anyway, so let's carry out the multiplication on the left hand side. So row 1, so this is going to be the result of the multiplication on the left hand side. Row 1 times row 1 times column 1 is going to give 5 times P plus minus 6 times Q. Then row 2 times column 1, so row 2, column 1 of our matrix is going to be 4 times P plus minus 14 times Q. There's just one thing I should point out. So we are multiplying this matrix by this, and we know the result is going to be a 2 by 1 matrix. So the outcome here is going to be what you get from row 1 times column 1. So I'll call that row 1, column 1. And if you think about it, in this matrix, this is the first row and this is the first column. So row 1, column 1. The next result is going to be whatever is going to be here, row 2 times column 2. So I'll just put it to you this way. This is a 2 by 1 matrix. It has 2 rows and 1 column. Whatever the element here is going to be what you get when you multiply row 1 of this first matrix by column 1. And the element here, which is in the second row and the first column, is going to be what you get when you multiply row 2 by column 1. And that's what we've done here. So simplifying this gives, well, this is the left hand side. Right hand side is still 7 and minus 22. So we can simplify this to give 5P minus 6Q as this result, and then this is 4P minus 14Q, and this is equal to 7 minus 22. So by comparing the elements in the matrices, because the matrices are equal, so elements in the same position must be equal, you can say that 5P minus 6Q is equal to 7, and you can say that 4P minus 14Q is equal to minus 22. So we have simultaneous equations. So we want to find P, so it would be a good idea to use the method of elimination to eliminate Q, and this can be achieved by multiplying equation 1 by 14, the coefficients of Q in, well, ignoring the sign in equation 2, and multiplying, well, equation 2 by 6. So I'm going to do that. So equation 1 by 14, so 14 times 5P is 70P minus, what's 14 times 6Q, that's 84Q, then 14 times 7, that's 98. And then equation 2 is being multiplied by 6. 6 times 4P is 24P. 6 times, so minus 6 times 14Q is 84Q. And 6 times minus 22 is minus 132. So I'll call this equation 3, and I'll call this equation 4. So I want to eliminate Q. All I have to do is add equation 3, well, subtract equation, well, basically carry out this operation, equation 3 minus equation 4. Because if you look at Q in both equations, the coefficient of Q in both equations is the same. They have the same sign, same magnitude. So if you subtract one from the other, it's going to disappear. and you're going to see that shortly. So here we have the equations again, equation 3, equation 4, and I'm saying equation 3 minus 4 to eliminate q. So let's carry out the left-hand side subtraction. So we have 70p minus 84q as the left-hand side of equation 3 minus the left-hand side of equation 4, 24p minus 84q. And then for the right-hand side is 98 minus 132, which is same thing as 98 plus 132. So note is 98 minus 132 because it's equation 3 minus equation 4. So bringing like terms, well, dropping the brackets gives 70p minus 84q minus 24p minus times minus plus 84q equals 98 plus 132, which is 230. Bringing like terms together on the left hand side gives 70p minus 24p minus 84q plus 84q equals 230. Clearly, minus 84q plus 84q is 0, so that cancels out. So we're left with 70p minus 24p, which is 46p. So 46p is 230. So p is 230 divided by 46, which is 5. So p is 5. There's a simpler way to solve this problem, and here's how it goes. So this first matrix I'm going to call A. This second matrix, which is also a column vector but it's a matrix, is matrix B. And this matrix I'm going to call matrix C. So what we have is a problem of the form of a matrix being multiplied by another matrix, and then the result is a certain matrix. So you need to use a certain identity, and the idea will be to solve for B. So you have PQ equals something so that you can just compare elements in the same position to find P. So we have a problem of the form AB is equal to C. But if you remember, if you multiply the inverse of a matrix by the matrix, you get the identity matrix. So if I multiply A by its inverse, whatever I did to the left hand side, I have to do the right hand side. So I have to multiply C by the inverse of A. So I'm just multiplying, well, so far so good. So the inverse of A times A is the identity matrix. So we have the identity matrix times matrix B is equal to the inverse of matrix A times C. I know that the identity matrix times any matrix is that matrix. So that gives B is equal to the inverse of A times C. So I'll just demonstrate this bit here. So the identity matrix for A is a 2 by 2 matrix. It has 2 rows and 2 columns. So this bit here, the identity matrix times B, is the same thing as saying, well, what's the identity matrix of matrix A, which is a 2 by 2 matrix? It's simply 1, 0, 0, 1 times matrix B, which is PQ. So I have a 2 by 2 matrix being multiplied by a 2 by 1 matrix. So it is a valid operation. I will get a 2 by 1 matrix, which is simply given by 1 times P plus 0 times Q, which is 0, and then 0 times P, which is 0, plus 1 times Q. And this is equal to P plus 0, which is P, and then 0 plus Q, which is Q. So what I've just done here is shown you that the identity matrix times B is B in this case. Anyway, so B, which is what we're looking for, is simply the inverse of A times C. So let's find the inverse of A and multiply it by C. So you know that if you have a matrix of the form A, B, C, D, so I'll call this matrix M, the inverse of such a matrix is simply given by 1 over the determinant of the matrix times D, A, then minus B, minus C. So I'm going to apply this to our matrix A. So our matrix A is 5 minus 6, 4, and minus 14. So A is 5 minus 6, 4, and minus 14. I'll rewrite this so it looks better. I'll just double check. I'll just rewrite it again. 5, I'll leave enough space, minus 6, 4, and minus 14. So what's the inverse of A? Well, inverse of A is equal to 1 over the determinant of A times, so you swap the positions of those two, so minus 14 and 5, and then you multiply this element by minus 1, so that gives 6, and multiply this element by minus 1, and that gives minus 4. What's the determinant of A? Well, the determinant of A is equal to AD minus BC, so it's 5 times minus 14 minus B times C, minus 6 times 4, and that's equal to minus 70 minus, what's minus 6 times 4? That's minus 24. So it's minus 70 plus 24. Minus 70 plus 24 is what? Minus 46. So we now know the inverse of A. The inverse of A is 1 over minus 46 times minus 14, 6, minus 4, and 5. So now back to the equation of interest. B is equal to the inverse of A times C, which I'm going to write here. So B, which is PQ, is equal to the inverse of A, which is now 1 over minus 46, and that's the same thing as minus 1 over 46, times what we had was minus 14, 6, minus 4, and 5. So this whole expression here is the inverse of A, which we determined earlier, times C, where C is this matrix, 7 minus 22. So minus 1 over 46, and let's just deal with this multiplication, and that gives, so this is a 2 by 2 matrix, a 2 by 2 matrix times a 2 by 1 matrix, so the result is a 2, well, the multiplication is valid, and then the result is a 2 by 1 matrix. So what do we get? We get minus 14 times 7 plus 6 times minus 22. We get minus 4 times 7 plus 5 times minus 22. Remember the procedure, it's this element times this element plus this element times this, and then for the next row it's this element times this plus this element times this. So I'm assuming you know how to multiply matrices. So minus 1 over 46, and that's equal to, well, let's see, minus 14 times 7 is minus 98, plus 6 times minus 22 is minus 132, minus 4 times 7 is minus 28, plus 5 times minus 22 is minus 110. So this is equal to minus 1 over 46, minus 98 plus minus 132 is minus 230, minus 28 plus minus 110 is equal to minus 138. Therefore, remember, we have PQ on this side. We want to get a form where we can compare elements in the same position. So we just want a simple 2 by 1 matrix on the right hand side. So minus 1 over 46. Remember, when you're multiplying a scalar by a matrix by scalar, you multiply the scalar by each element of the matrix. So we're going to multiply this scalar. So minus 1 over 46 is a scalar. It's just a number. We're going to multiply by each element. So minus 1 over 46 times minus 230 is 5. And minus 1 over 46 times minus 138 is 3. So by comparing elements, you can see that P is 5 and Q is 3. I'll just take the multiplication step. So minus 1 over 46 times minus 230, that's minus 1 over 46 times minus 230. Same thing as times minus 230 over 1. And what's that equal to? Minus 1 times minus 230 is 230 divided by 46 times 1, which is 46. So 230 divided by 46 you can easily determine from a calculator as being 5. The same idea is applied to when we was applied to the multiplication of minus 1 over 46 by minus 138. Same idea, we have 138 divided by 46, which is 3. So the rule that's applied is simple rule of multiplying a matrix by a scalar. So you have a scalar k times a matrix a. Well, let's start with a simple matrix. K times this is simply k times a, ka, k times b, kb. So the matrix will be of the same size. All you have to do is just multiply each element by the scalar. So you had a 2 by 2 matrix, for instance, a, b, c, d. K times, the result is simply k times a, k times b in that position, k times c, k times d. So I'll do a simple example. So you have 2 into this matrix, 1, 3, 0, 4. The result is simply a 2 by 2 matrix where 1 is now 2 times 1. 3 is now replaced with 2 times 3, which is 6. 0 is replaced with 0 times 2, which is 0. And 4 is replaced with 4 times 2, which is 8. It was the same idea we had earlier, but we had a fraction instead of a whole number. So we had minus 1 over 46. But you treat it the same way. So we had, instead of 2 in that scenario, we had minus 1 over 46. You treat it the same way, and obviously we had a different matrix to the right of the scalar. But that's a simple procedure.